Our second example is a tank that looks like this. A cone. The cone here is, we'll say that its diameter at the top is 12. So diameter 12 feet across, so it's a big old cone. And we'll say that the whole thing is 10 feet tall. And we will say that, I think that's all I need to say in regards to the size of the cone. I want to pump the water out. We'll say this time that the water is only filling the half of the cone. So if you put your water level in, it's only filling half of the cone. And I want to take that water and I want to pump it up to the top of the cone and then out this pipe that goes up even higher. And that pipe will extend, say, 22 feet from the cone's top. So I didn't draw this to scale, I ran out of board. So 22 feet above the cone top, so we got 10 feet to the top of the cone, and then in proportional drawing, we've got unproportional drawing, 22 more feet. So imagine it going up where I can't reach. All right, so to begin the problem, establish your X and Y axis. We're going to cut this cone right in half with our Y axis. And here's our X axis. So we're going to have this be water again. If I give you another fluid like oil or gas or diesel, I have to give you the weight density as well. So, all right, so we're going to start with work equals the integral of. And as you see, I'm going to take one particular sheet. This time, however, notice the shape of the sheet is not a rectangle. But we still, if you recall, we needed to have the volume of that sheet, we needed the weight density, and we needed the distance in our integral, and then we're ready to do it. So, all right, so Erin, you pick something and put in our integral.
Okay, I guess I'll do distance, maybe.
Pardon?
Distance.
All right, so if I pick this sheet, how far do I have to go to get it out the top?
You said it's halfway filled, so that means it'd be 5.
No, because...
Oh, just that one little sheet.
Yeah, just that one little sheet.
Oh,
So she's working on distance. That's pretty cool because that's the hardest thing to
I
do.
don't know, I picked that. I just
I call weight density.
All right, so she's got to
Water
go
density?
from here, and it
Yeah.
doesn't matter
That's what I was
where I
about to
pick
do.
the sheet. It's got to go
Sorry.
up to the top of the
Not
cone,
really.
which is 10,
Right,
and then
Gianni?
another 22. So we need to know, and this is hooked to the X, Y. This point is right there is X, Y. So this is Y.
Okay, so would it be 32 minus
Hello?
y?
It is. So is that so bad?
No,
She
it's
got the
not.
hardest part. 32 minus y. Because right here, no matter where I pick this sheet, I could pick it way down here near the beginning or wherever. The value is y from between my fingers. And from here to here is 10, and here to here is 22. So together, we've got to get 32. So 32 minus y will give us the distance for that sheet. What?
There's some flashing icon on this.
2. We're running out of battery. Running out of space.
Yeah,
I'll
I think
just
it's
go.
space.
Yeah. I for some reason I keep forgetting to undo it. When it runs out, I'll just finish this problem at home
Okay.
or whatever. So just let it go on down. All right, Brendan, you get the
4
pick up.
minutes left.
You got the pick.
3.
All right.
Okay.
You get the pick up.
Can I have 62.4
Yeah.
on the outside?
62.4. All right, we'll bring it out in a minute.
Okay.
All right, Morgan, you get the area of this circular sheet.
Speed it, slow it down the video.
Circular sheet has the area.
Oh, you have to do like pi r, all that
All right,
stuff.
so pi.
Pi r squared.
All right, pi r squared,
And
then
r is 6.
and the thickness of the sheet is very thin, infinitesimally thin. So what would be the thickness? 'Cause-
Oh wait, no, that's the y.
Right, dy, very
I was
good.
talking about the radius
All
is
right,
6.
are you up with us on this one, Jonathan?
Yeah,
I want
I'm
you
just
to-
writing the problem.
Can you stop and just eyeball radius for me? It's the purple part right here. What do you think its value would be, an x or a y?
That's x.
It is an x. So I'm going to replace r with x. However, there's a disconnect because we need to do this problem in dy. So how can we do that when there's no formula? Well, here is the function that this radius is attached to is this line right here. So if I had the name of this line, I could change x to y. So y equals mx plus b. So Aaron, what would be the slope of this line? Remember the top's diameter was 12, so this value is 6, and this value is 10. So if I went over 6 and up 10, what kind of slope are you seeing? Rise over run.
How much did you say it's up?
The whole cone is 10, and this value is 6.
So it'll be 10 over 6.
All right, so I went over 6 and up 10. Where did I get the 6? I knew the diameter was 12, so I knew half of it was 6. And I was given the height of the cone. So rise over run is 10 over 6. It reduces to 5/3. And where does it cross, Aaron, where does it cross the x-axis?
0.
Right, so I don't have a b. So now, Brendan, we need an x, we need a y in terms of x. We have to get rid of the x, so rearrange this so it's x equals
3/5 y.
3/5 y. So that wasn't so horrible. And then we have to square it. All right, Gianni, if we run out of taping space, I'll just leave that for you because that's all I'm going to cover today. And I'm going to assign 5 of these. 17, this is 7.5 again, 17, 18, 19, 20, and 21. Those are the first 5 tank problems. We're going to do 10 altogether, so we'll spend 2 days on
It's
this.
about to die.
All right, over and out. Get well. Be back soon. Bye.